Welcome back, everyone. In all of our previous videos, we have been building steady state models. That is, the inputs don't change with time, and we generate a single solution representing an average long-term steady state condition. Well, there's one of the things I always like to tell my students is that in reality, there's no such thing as a steady state aquifer. They're always changing, and while it is useful in many cases to simulate average or long-term conditions, it is very common in practice to build transient models where the inputs change over time, and we simulate the time-varying dynamics of how an aquifer responds to different stresses that are imposed upon the system. These are extremely useful and absolutely necessary for long-term planning. One of the most common uses of a model is to determine how an aquifer will respond to certain changing conditions such as climate change, over-utilization of groundwater resources, over-pumping of an aquifer, and how it would respond to certain management scenarios. So in this tutorial, we are going to explore the basic steps involved in setting up a transient simulation using the GMS software. And we're going to, in a nutshell, in terms of broad outline, I'm going to show you how to change a steady state model to transient and set up your transient inputs, set up the time stepping stress periods, and then how to some of the options available to visualize the transient output. So with that in mind, this by the way, so we're going to go through this particular GMS tutorial. It's available on the Aquavail website, and as is the case with the other tutorials, there's both the PDF and a set of files that I've already downloaded and unzipped, and we're going to open that file right now. So let's go up to, the file is called trans, and we have a start.gpr file that we're going to import. And you may recognize this. This is what we've sometimes called the Big Valley model. This is the same one that we use to learn about the calibration tools in GMS and automated parameter estimation and pilot points and stochastic modeling. It's a nice handy little exercise. And so after reading it in using the start.gpr file, I'm going to do file save as, and we're going to save this as trans1.gpr. And so this particular model has been set up using the map module in GMS, which uses this conceptual model approach. And the main feature of the conceptual model approach is that you can set up your inputs using points, lines, and polygons, and that is independent of the spatial discretization, the row and grid cell sizes. And then you can automatically generate your cell-by-cell input from this grid-independent conceptual model data. When we're dealing with transient data, we have a similar kind of issue in terms of the temporal domain. We can measure our stage in our rivers or lakes or streams at a particular date and time, or our pumping rates are recorded how they change at a particular date and time. But in terms of the model simulation, there's a time t=0 corresponding to the beginning of the simulation. Then in terms of the inputs, everything's measured with these things called stress periods, which basically is a measure from the beginning of the time period. So when you're bringing in data, it could be observation well data, or time series of stage, etc. You have to kind of translate that into simulation time. Now you can do that in Excel using some time function, but GMS will automatically convert that to the appropriate time scale for you when you do map to mod flow. So in a nutshell, we are going to enter some transient data into our conceptual model, and then we're going to set up some time step information, and then all of that conversion of our grid and time step independent data in the conceptual model will automatically be applied to the cells and to the time series the time step or stress period discretization that we define. All right, so to start out, we are going to create some transient recharge information. So I'm going to turn off the grid, and let's go down to our recharge coverage. And if you look at this now, we have a recharge rate which is just a constant rate for each of these polygons. I just do all, you'll see these steady state recharge rates. And we want to change the recharge rate for polygon number 2, this one right here. Now, if you're following along in the tutorial, there's this table of recharge rates which have been provided, and these are given in dates, a date time format, and then the corresponding recharge rate, which is in feet per day. And you know, these are actually, it'd be more accurate to describe these as dates because we're just using 12 a.m. on each of these, but you could have an actual time of day associated with it as well. And so this is how the recharge rates change over time for whatever reason. These are, once again, since this is a hypothetical, it's not a real site, we've made up some recharge rates to look at here. And according to the instructions, we want to go in and we want to edit, we're going to enter this table of information. But I don't really want to sit and type those out one at a time. And so I have this information transcribed into a table in Excel. And then I'm just going to copy paste the information from the table here. Okay, so let's go back to Excel, and let me move that. Let's see, I'm missing one other. Here we go. I want to move that out of the way. And so I'm going to double click on this polygon, and then in this window to enter the recharge rate, by default you enter a constant rate, but you can, using this little pull down, you can say, oh, I want to enter some transient information, and then that little button on top of it allows you to pull up a time series editor, and I'm going to turn on the use dates and times. Now if you wanted to, you could type these numbers in automatically, or use this calendar that to enter the dates, and then enter the corresponding recharge rate. But again, I'm going to go back to Excel. I'm going to copy that table right there, copy, and come over here to GMS, and I am going to, I'm trying to right click on that. Let me do it this way. There we go, paste. And there are the times from the table and the corresponding recharge values. Now over here you will see a time series plot of that, and it's input as a step function, or it's displayed as a step function, and that can be that's actually the way it's entered. For example, if you look here, there are two values for January 1st. So what that means is we want this, or this is changing instantaneously from that value, and then there are two values for March 1st. And so because of the way it's input, it's interpreted here as a step function. Now you could have it, I mean, it wouldn't have to be an input this way, and I can't remember the logic decided here, but if you don't have two values on the same date, then it will be more of a traditional, linear time series type appearance. But I'll click OK there, and that defines that input. Now we could go ahead and do this for the other polygons and copy paste values, but there's actually another way to do this. And instead of copying and pasting values, if we have them sitting in a file, there's another approach we can use. And so another file that comes with the input files we're using for this project, it's trans_recharge.csv. So this is a comma separated values file, and this is one of many simple CSV and text file formats you can import to GMS. And basically they're all just, well, we say a flat file. It's just the information is in rows and columns, just like tables of information. And there are a number of different kinds of things you can import. And we're going to import this as a time series polygon file. In other words, it's a time data that is then associated with polygon features. And so in the first column you have a series of IDs that represent the polygon IDs. And so here, this is these two polygons together form zone 3, and this polygon forms zone 4. You can see the names here. If I turn these all on, so we have zone 3, zone 4. So zone 1 is just 0. That's up here at the top. And zone 2, we've already defined a time series. So now we have two polygons that are identified as zone 3. And you can do that. You can share an ID, and that basically causes these two to behave the same or be associated with the same data. So this is 2, these two are 3, and this is 4. So in this file, we have data for zone 3 and zone 4. And the second column is the date, and the third column is a corresponding time value. So all we need to do now is we're going to select File, Open, and we are going to select the All Files filter, and here we go, transrecharge.csv. And we've done this before with other kinds of data, but it's properly delineated the 3 columns. So we go to the next field and we say we want transient polygon data. There we go. And the first column is the name column. That's already been identified. And the third column is the recharge rate time series. We just have to identify that. And it knows what feature to look for based on, and I kind of skipped over this, but when you import transient polygon data, you really you need to be in the map module, and the coverage you want to import the data to needs to be the selected active coverage, and it needs to be a polygon coverage. And so now I'm going to click Finish, and it says, do you want the time series to be a continuous step function or a step function instead of continuous? Well, it's a little confusing. You know, this information was entered in a step function because the time values are duplicated with different recharge rates, and so if we entered those without the duplicate values, we still had an opportunity to make it appear as a step function, but now we want it to be continuous. So we could, the point is, the way the data are formatted, we get the same answer either way. So we'll just select yes there. And now if we go in here and click on this, you'll see that we have that time series has been imported for us. And this one has been imported. That's the same one. And then this one has also been imported, and this is different than the one we had for the polygons, the 2 polygons associated with zone 3. And so that's pretty easy. And if you have that, you know, we did this for recharge, but it could be, you know, anything, evapotranspiration, you know, anything you want to associate with a polygon that you want to be time variant, you can import using this option. Pretty easy to do. Okay, I'm going to save those changes. Now the next thing we're going to import is pumping well data. If we switch over to the sources and sinks coverage, we have 3 wells, and we are going to change the pumping rate. Right now we have a constant pumping rate for each of these. And once again, if you come in here, you could say, I want that to be transient, and then you could enter a series of time values corresponding to t equals 0, representing the beginning of the simulation, or if you turn on dates and times, you can just enter those in date time format. This only has 3 wells, but in reality you might have hundreds, if not thousands of wells with transient pumping data. And so once again, it's something we want to automate. And associated with this set of input files, there's also a pumping data file. And again, it's a simple flat file. The first column is the well ID, and then the second column are the date, time, and pumping rate values that are used to define that the time series for each of these 3 wells. So we're going to do the same thing once again. We are going to go select open, and it's right there, pump.txt, and we'll go next, and we are going to say pumping data. So by the way, you could choose to do this in 2 steps. You can bring in a flat file with the well XY locations in 1 step, and then in the next step you could bring in the transient pumping data. But we already have the wells in GMS, so we're just going to bring in the transient pumping data. So again, we have to identify the columns. This one is automatically detected to be the name column, date, time, and then flow rate time series. It automatically got that for us as well. So we'll click finish, and let's see, we'll do it as a step function, because the pumping rate does not change linearly over time. You set a pumping rate and it's at that pumping rate until you change it, so we want this to be a step function. And so now if I go in here and click on this button, there's my pumping rate step function. Now when it's pumping, it's negative, and so it starts out at 0 and then negative 6,000, negative 14,000, and so forth. And let's look at the other 2. So that is well 1, this is well 2, and this is well 3. So we got those time series imported for all 3 of those wells, and piece of cake. So now we have transient recharge data, we have transient pumping data. The next thing we're going to do is look at storage coefficients. So for transient simulations, you need to have a storage coefficient, specific storage, storativity, specific yield. And since this is an unconfined aquifer, we're going to enter specific yield. And we're just going to piggyback that on top of our hydraulic conductivity arrays. So we're going to use this set of polygons here. And we're just going to use, let's see, we're going to use the shift key and multi-select these 2 polygons here, 1 and 2. Oh wait, I forgot something. I need to change the attributes of this coverage to turn on specific yield. There we go. And now I'm going to multi-select those, right click and select attribute table, and I'm going to enter a specific yield of 0.2. And then I'm going to select these others and attribute table and do 0.15. And so now I have 0.15 for these 2 polygons and 0.2 for these 2 polygons. Okay. So these up here at the southern end of the valley have a little bit tighter soil properties, slightly smaller specific yield. Okay, I'm going to save that, and we're about ready to do map to mod flow. But before we do that, we need to go to the mod flow global package, global options dialog, and we're going to change the model from transient to steady state. And when we do that, this stress periods button becomes undimmed. And here, what we do is we enter a date time corresponding to the beginning of the simulation, and then we enter the information about the stress periods. And so we're going to create a table here, and each row in the table becomes a stress period. In ModFlow, your time domain is subdivided into units called stress periods, and your inputs can only change at the beginning of stress periods. But within a stress period, you can have multiple computational steps or time steps. And so, for example, I could say, well, my first stress period is 30 days, and within that, I'm going to have 15 time steps, so 2 days time steps. And then there's the steady state option. It basically says, well, if you turn this on, what it does is at the beginning of your simulation, it will run a steady state simulation to get your initial conditions, and then it will continue on from there. We're going to turn that off because we're going to use a little bit different approach. And normally I would go in now and enter a series of values here defining my stress periods. But again, if you look in this spreadsheet that I have set up, I have a set of times and time values and the corresponding number of time steps. So I'm going to go in here, I'm going to copy these time values, and I'm going to go, I'm lazy, I don't want to type all these, so I'm going to go in here and I'm going to paste. Whoops, click the wrong button, darn it. Let me try that again. Copy and paste. Now when I do that, it automatically calculates the lengths because I've entered a series of date time values, and so it parses through the difference in those dates and it calculates the stress period length. Now if I go in here and I change this length, it will automatically update the corresponding start time of the next stress period. So you can either enter your stress periods by editing the length column or the start time at the beginning of each stress period. Either method works. Now for the number of time steps, I'm going to go back to my transient data thing. I'm going to copy that second column right here. Select copy. And then I'm going to paste this right here. And so this is the number of time steps we want in every one. These are somewhat arbitrarily defined. So, and up here at the top, we have, we can graphically select our stress period. So this is a linear representation of our stress periods and the corresponding time. And so the big tick marks are the stress periods, the small tick marks are the time steps. And so you can click on that either way and see the corresponding time step up here. So we're pretty much ready to go here. I'll click OK. Now if we go to the feature objects and select map to ModFlow and click OK. Some XY series do not cover the range of time specified by the ModFlow stress period. Values will be extrapolated from the information that is available. So what that's saying is some of these stress or time series terminate before the end of the simulation time, and so it's just going to use the value, the very last value in the time series and extrapolate that forward, which is totally fine. So now if we go into, for example, let's see, optional packages. Where's my recharge package? You'll see that now we have we can use this little selector up here to switch between stress periods, and those values will change as we go from one stress period to the next. And you can see those as you just kind of cycle through that. Okay. And what else we got? Oh, we have transient well data. So if we go to the well package, we could see the same thing as we could cycle through the stress periods. We can see how those pumping rates change. And this is how it's input in the native ModFlow file. So that all worked out great. Finally, the last thing we have to do is worry about the starting heads. Let me see. Let me save my changes there. So if I go to the Global Options dialog, we have this starting heads equal grid top elevations. Now that works great for a steady state simulation, but for a transient simulation, your initial head values should be equal to something that was solved by the ModFlow governing equations so that it's compatible with your boundary conditions at the beginning of the simulation. And so what we've done is, so when we read this model in, we had a steady state solution. And this steady state solution corresponded to the boundaries, to the inputs and the stresses at the beginning of each of those time series that we just entered. So it is consistent with it. So what we want to do is take this computed set of heads that were found by a steady state simulation and copy them to our starting heads array to represent the starting heads at the beginning of our transient simulation. So to do that, we just go into the starting heads dialog and we say constant, let's see, 3D data set to grid, and then we select our solution here, start head, click OK, and it copies those in. Well, it turns out, it looks like they were already copied in for us. So we're good to go there. And I'll click OK. Now we're going to save this one last time. I guess we could do check simulation. That's always a good idea. And it says specific storage values are all 0 in layer 1. That's okay. We're using, it's an unconfined aquifer, so our specific yield values we enter will be what we need. It shouldn't be converting to a, if you had multiple layers, then you'd have to have both specific storage and specific yield. But since we only have one layer, it's only going to use specific yield, so we're okay there. All right, save and run. And now it solves the equation once for each stress period, for each time step of each stress period. And this is it's a really small model, so it runs very quickly. It runs in about a second. We had all of those stress periods and its time steps solved for us. And now we're going to read that in. And when I click on the head solution over here on the left, you'll see there's this this little window appears down here that shows all of the available time steps as part of the output. So our solution here is a whole sequence, a transient array of head values. Now let's change our display options a little bit just so that is a little easier to visualize. Let's do the color fill and linear here. And let me turn off the conceptual model data. There we go. So that I'm going to highlight the top value here, and then I'm going to use the down arrow on my keyboard, and I'm going to kind of cycle down through those, and you can see the heads change over time. And this is a result of the recharge changing, and it's a result of the pumping rates changing over time. And by the way, it's a small model, so I can, if I press and hold the up and down arrow key, you actually get kind of an animation. You can't do that with really big models, but small models like this, you can do that. What else can you do? There's another tool I like. If you do the Create Chart Wizard, there's a time series. No, active data set time series, that's what we want. And so if you open that up and you just click on a cell anywhere in the model, it will show you a time series of the head at that selected cell. And so that's a nice way to explore your data. So that works out great. Now, what else can we do? I showed you how you can cycle through the different time steps down here. You can also go to the display menu and select the animate wizard, and this brings up the animate dialog. And let's see, we want display clock. These options have changed on me a little bit. We're going to go to the next thing. Oh, here we go. We're going to turn on a clock. We're going to tell it to do the entire sequence. You can have it subset to a certain sequence. Then I click finish, and what this does is it basically records a video and puts it in a Microsoft video file format, and then it launches this little AVI player, and this just allows you to play that. It has a little clock here showing the date and time, and you can always pause this. Let's do stop, and then you can grab this frame, this thing here, and it'll cycle between the frames. You can adjust the playback speed to speed it up or slow it down, and you can have it go forward and then back in time if you want. That's kind of nice, and then it tells you where that's saved. And so it's an actual video file. It says gms.avi, and you can open up a new one, but it saves it in the same file as your, I believe, as your project file, and so you can save that and use that elsewhere. So that's a really nice tool. You can also generate, I'm not going to complete this, but just to show you, let's see, display, animate. Instead of using an AVI file, or in addition to that, you can generate a KMZ file, which you can then read into Google Earth and overlay that in Google Earth and animate that in Google Earth, and that works really well. Now, I'm not going to do it here because this particular model is not georeferenced, but if you have a model that's georeferenced, then you can overlay that in Google Earth and or Google Maps, I guess. Maybe they're one and the same anymore, but that's another really great way to visualize your transient solution. So that concludes our tutorial, and my voice is going out now, so it's probably good timing. So in summary, you can enter your transient data in the GMS map module as time series, set up your time steps, map that over automatically using map to mod flow, and away you go. So building a transient model, it's more work. You have to collect and format a lot of time series data, but the overall process is pretty straightforward.